All right, we will continue on with this lesson by looking at some examples of regions where we can draw the region and then use a geometric shape to evaluate the integral, because we will be looking at the area under the curve. So in this first one, we have the integral from 0 to 4. So I need for us to interpret correctly. The 0 is the beginning of our interval, and so that would be A. B is 4, the end of our interval, and then our function, f of x, is the x over 2, which you might be a little more comfortable thinking of as 1/2 x. So first of all, we could draw what's going on. So that has a y-intercept of 0, 0, and the slope is 1/2, so up 1, right 2, up 1, right 2. Or we could have substituted in points. Substituting in 0 for x would give us 0. Substituting 2 for x would give us 1. Substituting 4 for x would give us 2. So this 1/2 x is a line. We're only interested in the line from 0 to 4. And now the shape is, as we go to the x-axis, the shape is a triangle. So if we calculate the area under that line bounded by the x-axis, we would have the value of the integral that we're asked to find. So the area for this triangle, for all triangles, is 1/2 times the base times the height. And so the base of our triangle is 4, and the height of our triangle is 2. So 1/2 times 4 times 2 is going to give us an area of 4, and therefore the integral from 0 to 4 of x over 2 dx would equal 4. We can calculate that by calculating the area. Now, you can also do integrals that are a little less determined by actual numbers. So in this integral, we're asked to find from negative r to positive r, the square root of r squared minus x squared. So I'm just going to I'm going to use 4 squares and call that negative r. And then because that's negative r, I want to be symmetric. And so I'm going to use 4 squares, call that positive r on the positive side of the y-axis. And then to get another point, I need to know what's happening. I could substitute in 0 for x. So that would be the square root of r squared minus 0 squared. And that would be the square root of r squared, which is r. So I would have the point I would have the point 0, r. And since I was using 4 squares, I'll use 4 squares. Now, this is a square root, so I need to at least have some sense of what shape this is. This would be a semicircle. So I'm going to draw my semicircle, and the radius of that semicircle would be r. So we have a radius of r. And on a semicircle, your area is 1/2, because it's a semicircle, and then pi times the radius squared. And since we don't actually have a value for r, that will be the value of our integral. So from negative r to r, the square root of r squared minus x squared would be 1/2 times pi times the r squared. And so you can evaluate using geometric shapes to get a number or an expression for the integral. We'll move on and take a look at some problems that use the properties of definite integrals. That will be examples 5 and 6. As you would work on these problems in your homework, be sure to pay attention to your given information. That's going to be very important as you evaluate. So you're asked to evaluate the integral from 0 to 7 of f of x dx. But in our given information, we have only information going from 0 to 5 and 5 to 7. So this would be property number 3 that we had in the previous side of the notes. We can split up this integral going from 0 to 5 of f of x dx, and then add to that the integral continuing on from 5 to 7 of f of x dx. And then knowing using our given information from 0 to 5, that's 10. From 5 to 7 is 3. And so the integral from 0 to 7 of f of x dx would be 13. And then for our second problem, we are asked to find the integral from 5 to 0 of f of x dx. So notice that I was given the integral from 0 to 5. So our second property said that if the upper and lower limits of integration trade places, then your integrals are opposite signed. So that would equal the negative of the integral from 0 to 5 of f of x dx. And that would give us a value of negative 10. And then in our example 6, you can also apply the properties when you have variables. So again, you want to make sure you pay attention to the given information. So we're told that the integral from 1 to 3 of x cubed dx is 20. And so if we are given 3x cubed, we can use the property that says we can pull the 3 in front of the integral. So 3 times the integral from 1 to 3 of x cubed dx. And then we know that that integral is 20. So this would be 3 times 20 for a value of 60. So our final answer on that one would be 60. So those are a few problems that use the properties of the integrals. And then we have one other example that is kind of a combination of using the properties and using the geometric shapes. So example number 7, I have a figure that we will use. You can see some triangle shapes, and you can see some trapezoids that we might use, or even rectangles. And something that you're going to need to know is that any areas that are below the x-axis will be considered negative. So areas below the x-axis are considered negative. So keeping that in mind, for our first problem, we're asked to find the integral from 0 to 1. So this shape is a triangle from 0 to 1, but it is below the x-axis. Now we have a lot of negatives going on in this problem. So I'm going to try to draw this out for you. First of all, the negative that is actually given to us in the integral, I'm going to pull that negative in front of the integral. So that would be the negative integral from 0 to 1 of f of x dx. And then, because this shape, this triangle, is below the x-axis, then I'll actually be doing the negative of the negative area. And the area in this triangle is 1/2 times the base. Well, our base has a length of 1 times our height, which has a length of 1. And you might even think of the height as -1 if that makes more sense to you. And so as we do that calculation, our double negative is actually going to create a positive. And so we'll have 1/2 times 1 times 1, and that's going to give us 1/2. So part A, your evaluation of that integral is 1/2. In part B, we're asked to integrate from 5 to 11. So from 5 to 11. So we're going to have to do a couple of shapes. So for the 5, we could go from 5 to 6, and we have a triangle that we could work with from 5 to 6. Then we could go from 6 to 10 and work with a triangle that is below the x-axis. And then we can go from 10 to 11 for another small triangle above. So I'll write that in symbols first. We're going to go from 5 to 6 of f of x dx. Because I'm going to be below the x-axis, I'm going to subtract the integral from 6 to 10 of f of x dx. And then back above the x-axis from 10 to 11 of f of x dx. And then I'll calculate the areas of the shapes. So the triangle from 5 to 6 would be 1/2. It has a base length of 1 and a height of 1. So 1/2 times 1 times 1 minus. Then we'll move on from 6 to 10. I have a triangle. So 1/2. Now the base from 6 to 10, that would be 4. And the height is 2. And then plus, I have another triangle from 10 to 11. So 1/2, it has a base of 1 and a height of 1. And then we'll just do those calculations. So we have 1/2 minus 4 plus 1/2. And when we combine those, we get -3. So there's part B. Now I want to separate this and do part C. On part C, I'm doing the same integral from 5 to 11, but this time I'm doing the absolute value of f of x dx. So what that means is that any shape that is below the x-axis, you just do the area as if it is a positive. So all positive areas. And so since we're doing the exact same setup as our last problem, don't be fooled into thinking that that's just going to give us +3. It will not. Instead, we'll be doing from 5 to 6, that would be 1/2 times 1 times 1. But then instead of subtracting, we'll add 1/2 times 4 times 2. And then we'll add 1/2 times 1 times 1. And so we'll get 1/2 plus 4 plus 1/2. And we'll actually get 5 as the answer to part C. And finally, then we will look at part D. For part D, we're asked to do the integral from 1 to 6 of f of x dx, of f of x, and then plus 3. So I'm going to clear my screen so I have a little bit more room to work on that problem. For part D, so first of all, let's take a look at the shape. We have 1 to 6. So from 1 to 6. And that looks like we could do easily a trapezoid for that. Now, I'm going to separate this. We're going to integrate from 1 to 6, f of x dx. That will be our trapezoid. But then I'm going to have to integrate from 1 to 6 of 3 dx. And we'll have to talk about that shape. So for my trapezoid, its area is given by 1/2 times the sum of my bases. So the first base from 1 to 6 would have a length of 5, and then my base that's on top is just from 3 to 4, so that would be a length of 1, and then the height of this trapezoid is 2. So that part of the calculation would be 1/2 times 6 times 2, and that's going to give me a value of 6. Now, I then have to calculate my area from 1 to 6 of 3 dx. I want you to think about what that is saying. So 3, if we think of that as y equals 3, that would just be a horizontal line. So we're going from 1 to 6, and we have a horizontal line at 3. So what we've really got is a rectangle that is a width of 5 and a height of 3. So we have an area of 15 for that calculation, and the whole value then would be 21. So you can think of this plus 3 either separate like I did, integrating that, or you can think of it as lifting up this entire graph. So lifting up this shape and putting a rectangle underneath it that has a height of 3 and then a width of, if you did the whole thing, it would actually go from 0 to 11. So as you're considering questions like that, if you have a number added to the end, remember that that lifts the graph up, or if it's negative, it moves the graph down. So those are some transformations that you'll be looking at as you do this assignment. Good luck on your assignment with Riemann sums, and continue to ask questions when you have them.